This is the Museum of the Earth in Ithaca, New York. It's the public natural history museum of the Paleontological Research Institution, or PRI. It displays fossils and other specimens from around the world and allows visitors to explore the history of the Earth and its life.
Hi, I'm Warren Allman. This is the skeleton of North Atlantic right whale number 2030. North Atlantic right whales are the rarest large whale species in the world today, with fewer than 400 individuals alive. She died a tragic death tangled in fishing gear in the summer of 1999 off the northeastern coast of the United States. She came here on a flatbed truck, and we buried her skeleton in horse manure in the backyard here, and then we assembled her skeleton over a period of about 2 years. She was brought into the museum when the museum was under construction. She was wrapped in plastic, and the museum building was completed around her. This extraordinary mural was done by a local artist named Barbara Page. She at first approached us here at PRI wanting to use our fossil collection as materials for this work, which of course we were happy to provide. But then we asked what she was going to do with the work when she finished it, and she said that she really had no plans, and we impulsively said, well, we'd love to own the mural ourselves. And that led to her completing the mural, and we planned the museum around it, which is why this ramp behind me goes down into the lower floor. We're going back in time as we walk along this mural. The mural is 544 tiles, one for each million years of the Phanerozoic, back to the beginning of the Cambrian period. On each tile are life-size images of actual fossils in an actual museum collection, either our collection or in another natural history museum in the United States. So it's a mixture of representational scientific illustration and more impressionistic presentations of transitions in Earth history, what different rocks looked like, and it's both a work of art and a work of scientific imagery. This is the beginning of the permanent exhibits here in the Museum of the Earth. The exhibits take a chronological tour to the entire history of the entire Earth through 4.5 billion years. And we take care of the first 4 billion years in this theater right here in about 4.5 minutes. And then we proceed at a more leisurely pace through the next 500 million years. This is our museum prep lab, which is both an exhibit and a research lab that allows our volunteers and interns to prepare fossil specimens for study, and also visitors can interact with the preparators and talk to them about what they do. All of our preparation here is done by trained volunteers, students, and interns. We're here at the entrance to the main gallery of the permanent exhibits in the Museum of the Earth. This large room tells the story of the last 500 million years, the Phanerozoic eon, which it begins with this event called the Cambrian explosion, which is the relatively sudden appearance of most of the major groups of animals in the fossil record, about 542 million years ago. This room is divided into 6 pieces, 3 worlds and 3 theaters. The worlds are moments in geologic time that are particularly well represented by the rocks in the northeastern United States. The theaters take visitors through the intervening couple of 100 million years between those moments. The first theater encompasses the history of the Earth and its life for the Cambrian, Ordovician, and Silurian periods. And then we go into a theater that encompasses the Carboniferous, Permian, and Triassic periods, and so on into the present day. This space encompasses about 500 million years and tells the story of the history of the Earth and its life through about 650 fossil specimens. That's a relatively high density of specimens compared to other museums, because the Museum of the Earth is the main natural history museum in New York State, between New York City and Buffalo, New York. So we tell that story using as many fossils as possible from the enormous collections of the Paleontological Research Institution. In this theater, we tell the story of the history of the Earth and its life between about 542 million years and about 410 million years ago during the Cambrian, Ordovician, and Silurian periods. This is the time right after the Cambrian explosion when life in the seas becomes established. Life explodes again in the Ordovician period, and then life becomes more common on land. We tell the story here through all the Earth, through all time, but we focus on the northeastern United States. In this part of the theater, we pay particular attention to life in New York State during the Silurian period, about 420 million years ago, when New York State was similar to the modern Persian Gulf, close to the equator, very hot, with a lot of evaporation on the shore of a shallow sea. And swimming in that shallow water was a group of animals that are now extinct called sea scorpions or eurypterids. Buried beneath Ithaca is a large salt deposit that is quarried today for road salt, and that salt formed by the evaporation of seawater in this shallow sea that lapped up around what is today New York State. The PRI fossil collections include specimens from examples of exceptional preservation, or Lagerstätten, including the famous Ediacara fossils from Australia, the famous Burgess Shale from British Columbia, and many others. And exceptional preservation is a theme throughout the exhibits in the Museum of the Earth. The big five mass extinctions of the Phanerozoic are also a theme of the exhibits in the museum. This is the first of those five. This is the extinction event that happened at the end of the Ordovician period, about 435 million years ago. The next period after the Silurian is the Devonian, which extends between 360 and 420 million years ago. The area behind me is devoted to the world of the Devonian, especially as represented by the rocks in New York State. The Devonian is the age of all the rocks in central New York, and most of those rocks are filled with abundant fossils. This wall is particularly popular with our museum visitors who live in central New York, most of whom are familiar with their abundant fossils that line their driveways and their gorges in their backyards. New York State is one of the most fossil-rich places in the world for the Devonian period, and this exhibit tells that story. Life came onto land for the first time probably during the Ordovician period, but it was during the Devonian period, between about 400 and 360 million years ago, that life on land really exploded, both plant and animal life. A lot of that history is told right here in central New York and northern Pennsylvania, and we talk about that story here in this part of the Devonian exhibit. We tell the story of the world's first forests, which are preserved not too far from Ithaca in the Catskill Mountains at a site called Gilboa. We tell the story of some of the first backboned animals to come onto land, which are preserved in northern Pennsylvania, not too far from here. And we tell the story of land plants that covered parts of the Catskill Mountains, what are today the Catskill Mountains, but long ago in the Devonian period were forests on the shore of a shallow sea. The Devonian is sometimes called the age of fishes because fish evolution exploded during this time. And again, fossils from New York and elsewhere in the northeastern United States tell a lot of that story. So we focus on fish evolution here in the Devonian World exhibit, including this cast of the skull of probably the largest animal in the world during the Devonian, the large armored fish called Dunkleosteus. The original of this specimen is in the Cleveland Museum. Notice that we only have its head because that was the only part of the body that was bony, that was easily fossilized. We reconstructed maybe what the shape of the tail looked like, but we really don't know. Most of these fossils come from either New York or Pennsylvania or in eastern Canada. This is the second of the three theaters in the main gallery. This theater tells the story of the Carboniferous period, the Permian period, and the early Triassic period. One of the highlights of the history of life in the northeastern United States during the Carboniferous period is the coal swamps. These were coastal forests that covered the area of what is now Pennsylvania all the way out to the Midwestern United States, Kansas to Illinois and Iowa. And these forests were dense coastal forests that when the trees and vegetation fell over into stagnant water and piled up over millions of years, they formed seams of coal. Up until recently, most of the electricity generated in New York State came from burning coal. That's no longer true. Most of the electricity in New York State today comes from other sources. But when we built the Museum of the Earth, we focused on the source of that electricity being burning coal. And we told the story, which is still true in parts of the United States and definitely true in many parts of the world, that when we burn coal today, we are releasing energy that came from the sun 300 million years ago and was stored in coal. So when we burn coal today, we are releasing that carbon into the atmosphere that came from plants that used the sun's energy and stored that energy. And 300 million years later, we're releasing that energy that accumulated over millions of years in just a few decades. In this area of the theater, we tell the story of the Permian and early Triassic periods when vertebrate life on land was expanding. The first reptiles and many large amphibians were walking around on land. Then we get to the biggest of the big five mass extinctions, the end Permian event, which completely reshaped life on Earth. It changed life in the oceans. It also changed life on land. It set the stage for the Mesozoic era, which we know as the age of reptiles. More than 96% of life may have become extinct in less than 100,000 years at the end of the Permian period, about 250 million years ago. After the end Permian mass extinction, at the beginning of the Triassic period, reptiles become the dominant land animals and diversify into many different forms. The oldest known dinosaurs and the oldest known mammals show up in the middle of the Triassic period. Dinosaurs go on for the next 150 million years to dominate life on land. Mammals are abundant and diverse, but they remain small and living in the spaces between the dinosaurs for more than 150 million years. We're here in the second of the three worlds in the permanent gallery in the museum, and this area tells the story of the northeastern United States during the late Triassic and early Jurassic periods, when the supercontinent of Pangaea was beginning to come apart. That supercontinent began to split in a rift valley, similar to what we see today in East Africa. That rift valley was filled with lakes, and in those lakes swam fishes, and along the shores of those lakes walked dinosaurs. So the story of the age of dinosaurs in the northeastern United States is really a story of dinosaur footprints and of fossil fishes that had once swam in these rift lakes, similar to the Great Lakes of Africa today. We tell that story here in this exhibit through fossils from that period and also with these murals that depict what today would be the cities of Hartford, New Haven, Springfield. The rocks that accumulated in this time come in two different forms. Brownstone, which is a red-colored sandstone, is very familiar building material in many northeastern U.S. cities. Many houses and many public buildings are built of this easily carved red sandstone. The other familiar rock to many of our visitors is a dense black basalt, which forms a series of rocks called the Palisades. The Palisades outcrop along the shores of the Hudson River, and millions of people every day drive past them. The Palisades are a massive basaltic lava flow that came to the surface of the Earth almost exactly 200 million years ago in one of the largest volcanic eruptions that's ever occurred. That volcanic eruption probably contributed to another mass extinction, the fourth of the big five, that took place at the end of the Triassic period. We tell that story here in the exhibit through this block of rock from Reading, Pennsylvania, in the eastern part of Pennsylvania, in one of these rift valleys that formed 200 million years ago as Pangaea was breaking up. There's only one locality in all of New York State where actual dinosaur fossils have been found, and it's in Rockland County, just a little bit north of New York City, in the Hudson River Valley. That's the only place where actual dinosaur fossils have been found, and they're not bones, they're footprints. And we have one of those footprints here in the museum that we collected expressly for this exhibit. and it really wouldn't be noteworthy, except it is one of the only known dinosaur fossils ever found in New York State. We don't know exactly what kind of animal made this, but it was probably a small, three-toed, carnivorous dinosaur, perhaps similar to a dinosaur called Coelophysis. Coelophysis isn't known from New York State. In fact, it's not even known anywhere in the northeastern United States. It's known from skeletons across the continent in New Mexico, in rocks of the same age. And we tell that story here in the museum as a way of explaining how paleontology works. Even though we don't have bones of Coelophysis in all of the Northeast, we think that a dinosaur very like Coelophysis lived here because of these footprints. Coelophysis is sometimes called New York's only known dinosaur because of this story, this connection to these footprints. And so we tell that story here as a way of engaging visitors in kind of the puzzle-solving process that paleontology often engages in. This beautiful model was built in 1904 for the St. Louis World's Fair. It's made of paper mache, and it depicts what we thought Stegosaurus looked like 120 years ago. The model went from St. Louis to Washington, D.C., where it sat in the Smithsonian Institution's National Museum of Natural History for more than a century. About 5 years ago, the Smithsonian closed those halls for renovation. They didn't want to reuse this beautiful model in the new exhibit, so they gave it to us here at the Museum of the Earth in Ithaca. It's no longer a good reflection of what paleontologists think Stegosaurus looked like, but it's a record of what we thought Stegosaurus looked like more than a century ago, and it's a beautiful piece of what's called paleo art. Millions and millions of people walked by this model in the century that it sat in Washington. And so it's actually a piece of the history of museums, as well as a record of what we thought this dinosaur looked like. We're here in the last of the three theaters. This is a very busy theater. Here we cover the rest of the Jurassic period, the Cretaceous period, and the Cenozoic up to the end of the Cenozoic, or the Quaternary. The Jurassic period is almost the peak of the age of dinosaurs. Most of the story we tell here is of the Jurassic in the oceans. We do that through the extraordinary fossils we have here in the PRI collections of marine animals that lived in Europe during the Jurassic period, including fossils from the exceptional preservation of the Solnhofen limestone in Germany, and these beautiful casts, which were made by Henry Ward in the 1860s. Ward's natural science establishment was established by Henry Ward to produce these casts and sell them to American colleges and universities. Cornell University, which is the origin of PRI, purchased a set of these casts, probably several hundred of them. Very sadly, most of these casts have disappeared long ago. This is some of the few that survive. So these are replicas of famous European fossils produced in plaster more than a century and a half ago. The Cretaceous period is the very peak of the age of dinosaurs, with many famous dinosaurs like Tyrannosaurus rex and Triceratops. We tell that story here, again, focusing less on dinosaurs than on life in the oceans, which is reflective of the collections here at PRI. So we tell the story here of mosasaurs and other marine reptiles during the Cretaceous period, and also of the abundant fossil invertebrates that are in our collection. Fossil invertebrates tell a story called the Mesozoic Marine Revolution, which is a complete change that took place in life in the oceans during the Cretaceous and in the following Cenozoic, in which predators expanded dramatically in the oceans and prey responded by evolving all kinds of defenses to those predators. This event, called the Mesozoic Marine Revolution, really established modern oceans the way we see them today, and that's one of the important stories we tell here in the museum exhibits. One of the most characteristic groups of marine organisms during the Cretaceous were the ammonites, which became extinct at the same time as the dinosaurs at the end of the Cretaceous period. One of the most bizarre things that ammonites did during their evolution was they became uncoiled. Most ammonites were coiled in one plane, but many groups of ammonites became uncoiled. That is, they didn't coil in one plane, and these are called heteromorphs. And they're some of the truly most bizarre organisms in the fossil record. This is one of the world's largest heteromorph ammonites. It was discovered in Antarctica, on the tip of the Antarctic Peninsula at a place called Seymour Island. The best way to think about this fossil is to think about a large trombone with a squid stuffed in it. These animals probably floated close to the bottom and were probably carnivores. Nothing like this is alive today. It's truly an extinct segment of an ecosystem. But ammonites were one of the dominant groups of organisms in the oceans of the Cretaceous, and they became extinct about 65 million years ago. The end of the Cretaceous is probably the most famous of the big five mass extinctions, and it was one of the largest. This is the event that saw the end of non-avian dinosaurs and the extinction of many organisms in the ocean and also on land, including our beloved ammonites. So the end of the Cretaceous extinction is represented here in the exhibit by this block of rock, which was collected in New Mexico, and like our block of rock from the Triassic-Jurassic boundary, represents almost exactly the last few years of the Cretaceous and the beginning of the Cenozoic. That red arrow points to a layer that probably literally records the fallout from an extraterrestrial impact that happened in the Yucatan Peninsula, and blue material exploded it all over North America, including where this rock accumulated in New Mexico about 65 million years ago. The rest of this exhibit tells the story of the aftermath of that mass extinction, the recovery, when life in the seas reestablished itself and rediversified to become the ocean life that we know today. PRI's collection is one of the largest in the world of Cenozoic mollusks and other marine invertebrates, and so we highlight some of that collection here. This image was produced by the U-Haul Corporation, which has a series of images, one for each state in the United States, on its rental trucks that drive around the country. This one is the official graphic image for New York State that is apparently on more than 6,000 U-Haul rental trucks driving around the United States. So if you're out on the highways of the US and you see a mastodon drive by, it's actually this image of a mastodon skeleton right here in Ithaca, New York. We're here in the last of the three worlds. This is the world of the Ice Age in New York State. And behind me is an extraordinary fossil. It's the skeleton of the Hyde Park mastodon. Mastodons were distant cousins of modern elephants. The American mastodon lived across North America, from the east to the west coast, from Canada to Mexico, up until about 10,000 years ago, when they and many large mammals became extinct across North America. New York State is filled with many, many mastodon fossils. More than 140 mastodon skeletons have been found in New York State over the last 300 years. PRI excavated this skeleton in the summer and fall of 1999 in the Hudson River town of Hyde Park. It turns out to be one of the best preserved, most complete skeletons of this extinct proboscidean ever found. Behind me, all the bones you see here are actual bones, not casts, except for the tusks, which for weight reasons are casts. But behind me is one of the tusks, which is essentially just slightly stained ivory. The bones themselves are also contain most of their original material. They're just stained. So this is an extraordinarily well-preserved fossil, and it's almost perfectly complete. We're missing just a few bones in one of the front limbs. Other than that, all the bones are present here. When we excavated the site, we not only collected the bones, but we collected the mud, which contained fossil shells, fossil wood. A whole ecosystem was buried in what was, when this mastodon was alive, probably a peat bog. That peat bog filled up over the following 13,000 years and became a wet spot. That wet spot became a pond, and that pond was in the landowner's backyard. He wanted to deepen the pond for recreation. He hired a backhoe. The backhoe dug into the pond and discovered bones of this mastodon. The theme of the last of the three worlds is climate change in the big picture. And of course, the biggest episode of climate change in the last few million years in the northern hemisphere was glaciation. Glaciers are very familiar to many of our museum visitors because the landscape of Ithaca was shaped by the glaciers over many advances and retreats of the ice in this part of North America. We tell that story here in the context of climate change. The map above me was purchased by Cornell more than a century ago to teach physical geography. It shows what North America looked like at the last glacial maximum, about 20,000 years ago. It's still strikingly accurate, even though it's more than a century old, and it shows how Ithaca and New York State was covered with probably more than a mile of ice up until about 20,000 years ago. The ice began to retreat, and the landscape that we live on here today in Ithaca is the result of that glacial melt and retreat over the last 20,000 years. So we tell that story here in this exhibit, also with this walk-in glacier. This walk-in glacier tries to get our museum visitors to think about what glaciers are like both in the past and in the present. In the past, when glaciers shaped the landscape here in Ithaca, and in the present, when glaciers elsewhere in the world are retreating because of global climate change. Finally, in this area, we have what may seem a little out of place in an exhibit with a glacier, but a pair of aquaria that contain living coral reefs. Why are corals juxtaposed with a glacier? Because modern coral reefs are endangered by the same climate change that today is shrinking glaciers. So we want people to not only enjoy the beauty of these living corals and their associated animals, especially the colorful tropical fish, but we want them to think about how climate change affects both glaciers in cold places and coral reefs in warm places. Our coral reef aquaria here at the museum are very special because this is one of the few places in the eastern United States where you can see a Caribbean coral reef ecosystem juxtaposed with an Indian Ocean coral reef ecosystem. These corals came from a Cornell professor, Dr. Drew Harvell, who maintained them as a research resource until about 8 years ago when she decided to close her laboratory. And she was looking for a good home for these beautiful animals, and we acquired her collection and built this exhibit of aquaria around these living corals. So here in upstate New York, far from the ocean, and certainly far from warm ocean, we can have corals that live today in the Caribbean, for example in the Florida Keys, and corals that live in the Indo-Pacific, across the Western Pacific and the Indian Ocean. These two ecosystems are very, very different. Indo-Pacific coral reefs are much more diverse, more species rich than Caribbean reefs, but one thing both coral reef ecosystems have in common is they're extremely endangered today by many factors caused by human activity, but one of the main factors is climate change. And that's why our coral reef aquaria are here in the climate exhibit part of the museum, to tell the story of what is happening to these beautiful modern ecosystems, some of the most diverse ecosystems in the world, being affected by modern climate change that is in large part caused by human activity. This is our walk-in glacier. It's a simulated glacial cave, an opening in the base of a glacier where water is flowing inside the glacier and water is flowing out of the glacier. There are rocks along the bottom that have been moved by the glacier. So we want this to be an immersive environment to get people to think about glaciers as dynamic systems. It's also the passage to the present. This ends our tour of the Phanerozoic of the last 500 million years. And as we walk through this glacier, we're walking through a passageway to the present. Thanks for joining me today, and come visit us at the Museum of the Earth.